been easier to just have 3 separate arrays for each color, but I kind of went back on that when I noticed how much logic I would have to do to make sure that everything get back in the right place.
Yeah, and I'm gonna show how I do dice handling today, and I think you'll agree with the approach.
Okay.
Right, so there's Baron, there's Lane Allen, there's where's Sierra?
I don't. I think she's getting caught up on mod op stuff, but I'm not sure where she's at.
Okay. And then I saw Dope McGee. I know he's over at Capstone, and then Becker's right there. I think she might be also. Belkowski and Bell and Blank and Lemuel. There you go. And I know, right? And then Borges, I don't see. Is Borges here? I saw Ebert a moment ago. Where's Ebert? Right there in front of me. Where's Borges? We don't know. Okay. Brandel is online, and Brazelton is nowhere to be seen, and Bert is online, and Bird right there, looking good in that Newmont College beanie. Cabrera and Cacalda and Carey, and I know where B is, and Cisneros is in the back, and Clark the first and the second, and Collins and Conlon, and Milk Kramer, Crawford, Daisley, and Dragoo. Where's Dragoo? Oh, he's online. And Duff and Durant is online, and Ebert is here, and Martinez is in the back, and McCleary is online.
Yeet Lomo.
What's that?
Yeet Lomo.
There you go. Perfect. And Antwerp, I know Crow is here, Nancy and Daniel, and my fella. There we are.
I'm actually getting really bad lag, so I'm gonna restart my computer real quick.
Okay.
Bring in the class date. I'm willing to bust that door. Like, Spark Cranberry.
Oh yeah.
I will have Tobin pre-close that door, and he'll be like, "So Thursday's time of the year," and I'll come out like, "Spark Cranberry." Bad, please. I don't know how, but out of the like, it didn't ever bring that inside joke to like all my housemates. Well, they decided to bring it up out of nowhere. Very good, man. Caffeine.
Choose the second one. Don't worry, you've got plenty of years before you develop a kidney stone.
So we're doing nothing on Monday, basically.
No, we're not doing nothing on Monday. We're doing the best thing on Monday.
So can I bring Smash Bros?
Yes. We haven't decided yet. We'll vote on it as a class.
I'm bringing Smash Bros.
All right, so
Ultimate time.
hey. So here is how this is going to go for the remainder of the week. So today is Tuesday. We didn't have class yesterday because of the all hands meeting. It was not. It was not our Christmas party.
It seemed like a pretty big.
We had a team building activity.
Everyone's favorite thing.
My team won. Anyway, so
It sounded like you guys were having fun.
we were having tomfoolery.
It was loud.
It was loud. Yeah, we do have the all hands meetings are actually pretty enjoyable in general as meetings go. But it was a more administrative type thing. Our company Christmas party is next week. And that's where it's way more low key. All right, so last year we got these. That's where these came from. Was our Christmas party. I love these. I like live in this. It's like my second skin. Yeah.
I'm wearing it all the time. Never gets in the wash.
And then it needs to get in the wash. Yeah. This is going on 2 weeks. Like this is my second week. I'm like, yeah, this will get washed at the end of the week. I really don't. I don't know what you smell like when that's not on. Anyway, so
I smell good. Don't worry.
I believe you. Sure. Anyway, so hey, I'm working on grades. All right, so here's how this week is going to go. First of all, on Friday, I have this thing in my brain that I want us to do, but I've got to work on the pragmatics to make sure that it will work out. And it will be fun, but it will be coding based fun. It will not be the projects you're working on right now, and it won't be for a grade. It will be for proof of concept, basically. It'll be fun. That's if I can make the pragmatics work. Now, if the pragmatics don't fall into place, if it doesn't make sense in terms of a good use of our time, we won't do it. But I'd like to do this thing. But I'm telling you this because that means that on Friday you should not count on in-class time to get your homework done, because we may not be doing that. We may be doing something else. On Monday of next week, at the start of class, at the very start of class, at 10:30 a.m. Whoa. On the 10th, what magically happens? All aside, stop. What? All deliverables stop. Right?
Wait, what day?
Yes, 66.
Wait, what day?
Monday of next week.
Okay.
So the 10th.
For some reason I heard Thursday. It's like, no.
Nope, that's not true.
No. Don't do this.
So now, just to be clear, the graders and I reserve the right on a case-by-case basis to say, hey, you know what, you're super close. You've got one more hour, give this thing to me, right? We reserve that right because the learning is more important than the points. However, generally speaking, the rule will be if it's not delivered by 10:30 a.m. on the 10th, it's just dead. That will be the general rule. We reserve the right to give special extensions on a case-by-case basis. So far, so clear? Okay. So have all your work done on Monday. Also, let me just put this out there right now. I know how school works. I know how this goes. This is not a shock to me. I've been doing this for 10 years now, between being a student and being a teacher, right? But Monday is the cutoff. Sunday night will be the waterfall of messages to me about I'm stuck on something. I just want to tell you right now, while I will be responsive for a period of time, I'm not going to take your emergency and make it my problem. Okay? So Sunday night, when I'm spending time with my family, I'm not answering your questions. You can ask them to me all you want, and it's up to me as to whether I respond to them. That's always been the rule. But don't be surprised if on Sunday night I become less responsive than normal. It's because it's Sunday night and I'm relaxing. And I've given you 2 full weeks of just work time where you could ask me any question at any time. And we've waited until the very last day to ask some important stuff, right? That's what happened with Zombie Dice Part 2. I got messages Sunday night, whereas I had not seen communication from those people beforehand. And they're like, I'm stuck on handling the dice. I'm like, you mean the entire effing game? Okay, cool. Let's talk about that, right? But it was like Sunday night at like 11 p.m., midnight. And I'm like, you're just asking me this now? Of course I want you to ask me questions, but I want you to ask them in timely fashion, right? And I had people that were like, I'm so stuck. I got a message from one person, and it's public. It's on the Discord, so I could talk about it. But I got, like, it was the day of, but before class had started. And some students were commiserating, and this one student was like, I'm just flailing in the dark. I have no idea what to do. And I'm like, then why didn't you ask me questions? And his answer was, and I quote, I've been winging it, or I'm winging it. And I going for you, right? Because that's like, why is that a plan? That's not a plan. That's a reaction.
It's a perfectly good plan.
That is a plan.
It is a proven plan. Just wing it.
It's working for me. I mean, I have an A in this class, or a B- in this class.
I did not ask you to say your grade out loud.
Oops.
The law requires that I say that. Anyway, so because of FERPA, if you say it out loud, that's perfectly fine. There's no FERPA violation. If I tell you to say it out loud, that's a problem. And I did not. So there we go. I did not ask you. I did not.
Okay, tell me, Usao.
Oh, hi, Mark.
What a story, Mark.
All right.
Watch that.
I have a clean version of that movie, so we could watch it. I didn't do the edit on this one, because if I had done the edit, it would have been much better edit. But the guy who did the edit, there is I have a pretty strong stance of I don't want to show things with nudity in class. I don't. And I stay away from the rated R stuff because we often have visitors and sensitivities, and I'm totally sensitive to all that. I have a clean version of The Room. They leave in one F-bomb because the way he says it is just ridiculous. And when there's a scene where he's remembering his time with Lisa while he's like dry humping her nightgown. But anyway, spoilers. Anyway, but there's like a flashback where she's naked, and there's like 2 frames of that got left in there. So there's just like this brief flash of a naked lady, and I'm like, gosh, freaking dang it. But I've got the video, so I might as well just cut it down some more. I can do that. I have the power. But yeah, The Room is fantastic.
There's another movie that he directed.
Okay, so you know how Fruitcake is actually terrible?
No, it's great.
Hang on. Listen, Mr. Anderson's talking. Oh yeah, gotcha. Yeah, you know how Fruitcake is terrible and awful? It's still a Christmas tradition, and it's everywhere all the time. Okay, it's kind of like The Room in movies. It's like, it's bad. Everyone knows it's bad. Nobody actually thinks it's a good film, but it's bad in the most enjoyable way possible. Danny and his drug problem. It's the best. You're tearing me apart, Lisa. It's gonna be great. Yes. Tommy Wiseau.
I know how you feel now. I was just kind of like background noise and working at homework and doing other stuff. So I was watching American Horror Story. It's literally softcore porn.
Yeah, you know, I actually watched.
Show, but it's literally softcore.
It really is. I watched a few seasons of that, and when I got to the hotel season, I like first episode. I was like, I'm out. I can't do this anymore. This is like this. The first. It is interesting. I absolutely agree with you. When it's not that stuff, it's really compelling. But man, it is like they push it as far across the line as they can get without being Skinamax, right? And I was like, should I even be watching this? Like, this is not my normal fare.
One time I was like, sometimes I just like bring videos back. I was in the bathroom.
Yeah. No, dude, that's what phones and tablets are for, bro.
And I'm like, no, it's my show. Sorry.
Yeah. It's like, yeah, I swear, this isn't porn, but you wouldn't know the difference. All right, so let's talk about Zombie Dice Part 2. Now, I checked the grades this morning. I checked the assignments this morning. It was due yesterday because, remember, even though we didn't have class, it was not a fully canceled day, so it was still due. And as of today, just before class, out of 38 students who have not effectively dropped this class, 18 did not deliver. So that means a little more than half of you did, which is good. But we had 20 who delivered and 18 who didn't.
Wait, did you just say 38 students dropped this class?
No, I said.
Oh, okay.
I said who haven't effectively dropped this class. So out of the 38 that have not effectively dropped, 20 of you delivered, 18 did not, which tells me that there are some hangups. And based on the messages that I was receiving in the 11th hour, the biggest problem that I saw was trying to figure out how to manage the dice in a useful way, right? Because in part 1, we had a consistent ratio. Every time you drew a die, there were constant factors that determined if it was going to be green, yellow, or red. But in real zombie dice, every time you draw one die, you have now effectively changed the ratios and the probabilities that you will draw a die of a given color the next draw, right? So when I start, I have 13 dice. And if I have 6 greens, that means I have roughly a 46% chance of drawing a green die. If I then draw a green die, I'm now down to 5 green dice out of 12, which means that my chance of drawing a green die is more like 43%. And then if I draw another green die, it's now dropped to about 36% or something like that. I forget what it was. Hang on a second. Calc. If I have 4 divided by 11, yeah, I've got about a 36% chance of drawing a green die. Meanwhile, however, that is the exact same percentage for yellow out of 11 dice. And if we have 3 divided by 11, that is now the percentage for drawing a red die. So you can see that drawing a red, yellow, or green die is almost the same percentage once you get to 11 dice if you drew 2 greens to start. However, in the very beginning, drawing a red die was only 23%. So every time you draw a die, you modify the probabilities for all other colors, for all the colors, for all the dice. Probabilities change. So the easiest way to manage that is to have all 13 dice ready to go, and you're just managing those 13 dice. You're not managing probabilities, you're managing the dice. Probabilities will take care of themselves. I'm sorry, Mr. Clark, what was the question?
I don't know, I forgot. I remember. So what question am I? I forgot.
Well, you're too busy being funny to be, useful.
I forgot after we were talking too long.
Yeah, I know. Yes.
I was like being lost.
So I was talking about probabilities, talking about drawing a green die, and then we were talking about like 5 out of 12, 11. Okay, that's fine. I'm not going to talk about that just yet, but I will. Or I'll help you with that in just a little bit. All right, so I wanted to show you how I manage dice in Zombie Dice Part 2, because I want to show you how we can think like engineers to simulate the outcome that the users expect. So for purely for proof of concept, you don't need this in your assignment at all, but I want to show you that I have 13 unique dice, and I want to prove that to you. So I'm going to create this private static int called nextID, and then I'm going to make a private final int called ID. Now, consider those 2 lines of code for a second. What?
So with the inventory of health pots and the magic potions, do they have a full inventory already?
They start with an empty inventory with the capability of holding 5 each.
Then would you suggest using like an int, or would you suggest for each spot? If that makes sense.
Well, I suggest that you have an array of type health potion and an array of type mana potion, because you're holding objects. The potions themselves are complex objects. They're not just insert chars. All right, so look at those 2 lines of code, lines 9 and 10. Okay? Consider what I've written there. How does that what? First of all, number yay. Oh, I want to borrow that. I don't know. I've lost weight. Good save. We're gonna have an ugly sweater contest this week, and I wanted to wear one that had a llama, and it's brilliant. It really does. Also, could just be like the Grinch's aunt or something. But anyway, yeah, it looks great. I love it.
Can't unsee that last
Right? You really can't. All right. So those 2 lines of code, notice line 10. Line 10 is different than I've ever taught you when it comes to finals. What is interesting about that line? Say again? Oh, it's not adding to a final. No, it's not. What's that adding to? Yeah, but what's interesting about the way I'm setting it, though? I'm setting it to a dynamic value. Now, when it gets set, it takes whatever that current value is, and that's in concrete, that's permanent, right? What's interesting is that that is an instance final. It's an instance final. And where have I taught you to set instance finals? Where do we set them? In the constructor. In the constructor. That's not in the constructor, but that happens during construction. Because that's an instance field, it doesn't come into being until we're building the object by calling the constructor. And I'm setting it to a dynamic value where it's going to use the value as it currently is. It'll store that value, and once that's done, it increments the dynamic one. So the first die I build will have an ID of what? 1. The second die I build will have an ID of 2, and so on. Now that die, that ID will always be that ID. Once it is set, it will never be able to be changed. But it's based on a value that changes over time. Why are there zebra out there? Anyway. All right. So does that, yes, sir. The plus equals takes place right now before you get the value back. This one says, hey, use the value as it currently stands. Once you're done using the value, then increment. Yes. Effectively, yes. Effectively, yes. All right, we good? And then I keep, why do I have this field as static, by the way? Why did I choose static on that one? No. 32. Yeah, that sounds great. I don't even know what that looks like yet. All right, so. Well, why do we start? Why is it static? But why is it static? Correct. So why is it static? Well, yeah, but that's why ID is final. Why is next ID static? That one right there. That next ID gets tracked at the class level, which is why it's static. It's at the class level. Because if it was at the instance level, it would just be the number 1 every single time, because every time I make an instance, I make a new one of those fields. I need this field to be shared or at the class level so that it maintains its state no matter how many times I build a new die. It keeps incrementing at a global level, not at an instance level. Yeah, one more, and just to be clear here, I heard multiple answers that sounded eerily like it's static because it never changes. That's not what static means. That's what final means, right? Static means it belongs to the class, not the instance. The instance can see it, the instance can interact with it, but it's stored in one spot in the class as a global idea. And by doing that statically, it belongs to the die class, not the individual instance. So every instance is allowed to increment that next ID, but it's a cumulative effect as opposed to resetting every time I build a new one. There we go. All right, and again, this is purely proof of concept. You don't have to have this in yours. Not a problem. So bump that down here with an SB dot append. Oh, come on, freaking Eclipse. Got to stall out for a second. There we go. That, and then up here, we'll do I'm going to do a number symbol, and then an append, and then the ID, and then an append, because we want to avoid concatenation. And then I will do a space hyphen space. There we go. Okay, so this is me just adding number, ID, space hyphen space, then it'll have color face of the die, right? That way we know which die we're using. And again, I'm doing this just so I can show you that I have 13 unique dice and that I'm just using those same dice, not making brand new ones over and over again. Cup is really where the biggest changes take place, okay? Because right now we've got these constants that don't mean anything anymore. We've got this draw die method that doesn't actually do what we want it to do. So we're going to change all that. First, I need a private static die array of dice. And instead of making a new array of size 13, I'm going to make a new array where I create each new die because I know exactly which dice I need. I know exactly which dice I need. So go ahead. I just commented out the constants and the body of draw die. I kept the draw die method. I just commented out its body. Probably because you accidentally commented out a curly brace you shouldn't have. Bless you. We good? All right, so I'm going to make a new green die. I'm going to copy that and pasta 5 more times. Now I've got 6 green dice. I'm going to go a 6th time, but then change that green to a yellow. And then copy pasta. I made a new array of die at the class level, and I made it static because my cup class is behaving statically. Because static has nothing to do with constant. Static has to do with class versus instance. Class versus instance. In the cup class, I have no need to have an instance of cup, so I just have everything static in cup. So far, so clear? Notice that you have comma-separated values until the very end. And while you can put a comma there as a statement of intent, I take the comma off. So does everyone understand that I have 13 dice where I have 6 green, 4 yellow, 3 red? Awesome. Okay. Now, I'm going to make a new method, a public static void method called shake the cup. What do you think shake the cup does? It does. It randomizes the sequence of the array. Also, I forgot something that we're going to need. You can place this anywhere as long as it's at the class level. Private static int dice drawn starts at 0. This is my counter for how many dice I've served up. Yeah. That's what shake the cup is going to be. So let's talk about that for a second. So the question is, do you really need that if you could just generate a random number between 0 and 12? So in other words, randomly choose a die. Okay, so if I take that approach, if I randomly choose an index, how do I prevent the same index from being chosen twice before the cup is reloaded? Mm-hmm. So, okay, so I see what you're doing. Okay, so the way that Mr. Bird solved it was when he removed that die, he physically removed it, he set it to null, and then he created a brand new array that was shorter, which is actually pretty smart. And the reason that's pretty smart is because what most people do is when they vacate a die, they just leave null there, but they don't change the size of the array. And what happens is as they eliminate dice, it becomes harder and harder to randomly choose one that's not null. And so then more and more cycles have to occur. And eventually you get down to just one die that you have to randomly choose. And that can take a while given certain probabilities. And so then you finally choose that random die, even though it's not random, it's the last one. Mr. Bird, by reducing the size of the array, never has that problem. However, what problem do you have? The problem is every time I draw a die, it takes at least 3 operations, 4 operations, right? I got to randomly choose an index, got to get the die from that index, and store that. 5 operations. Got to set that spot to null. Got to create a brand new array. Got to copy every new array without the null. So when we're talking about 13 dice, I've got to do 12 copies, which are 64-bit copies. They're addresses. It's not huge, but I got to do 12 copies. Then I got to do 11 copies. Then I got to do 10 copies. Yeah. You just skip over that index. Okay, so one operation saved. Still got to do 12 copies into a brand new array. And then I still got to store the new array in the old array spot. Small operations, but they're nickel and dimes, right? Nickels and dimes. It adds up over time. And if you and while we're in a small set, it's not a big problem at all. That's a good solution. That's a good solution. The solution that I have never requires that we make a new array, never requires that we make new dice, never requires, I know you didn't do this in your solution, but a lot of people did this in their solution, never requires setting a spot to null. Yes. Mr. Vella. Thank you, Mr. Anderson. By the way, you look great. Capstone? Nice. What time? 2:25? 3:25. I might be able to make that. What room? 207. All right, so I keep count of how many dice I've served up out of 13. So I start with 0, go up to 13. Down here in Shake the Cup, I'm going to make a random RNG, and I'm going to declare an int, because I like to be sufficiently random. I like to be sufficiently random. I like to be unpredictably sequenced. So this is a little bit of overkill, but it gives me high confidence that everything is as random as it could reasonably be. I'm going to have an int called sets. There's this algorithm out there. And we'll make all the sets jokes. Just wait. There's an algorithm out there all about taking any collection and taking 2 items in the collection and swapping their position. And by randomly doing this, you will randomize the sequence of the collection. This algorithm is referred to as Fisher-Yates, because those are the guys, those are the people that came up with that. Fisher-Yates. Where have you heard of Fisher-Yates before? Deck demo. This is how I know who's actually looked at the deck demo write-up. Because Fisher-Yates stands out pretty well, right? There you go. So yeah, so the idea of Fisher-Yates is you start at one index, randomly choose some other index, swap their values. Is it possible that the index you're at and the index that's randomly chosen is the same index? Yes. Is this okay? Yeah, this is okay. It's possible that when I shuffle a deck of cards, given any card in that deck, that card may relatively remain where it started. It may have started as the 14th card before I shuffled. It may end as the 14th card after I've shuffled. I don't really care. As long as the rest of the deck is sufficiently random, its position is technically random, just coincidental. So if we consider, if I start at index 0 of the dice array, and I randomly choose some other index, swap their values, then move to index 1, do the same thing, go to index 2, do the same thing. If I do that for all 13 indices, that's one set. So I want to have a random number of sets between like 5 and 12. Between 5. So I don't know how many sets it's going to be. I just know it's going to at least be 5 sets and at most 12 sets. Cool. How do I get a random number between 5 and 12? Go ahead. Okay. So what goes here? Why 8? Why 0 to 7? Yeah, we can look at it that way. We could say, okay, what's our range? Well, let's subtract the minimum from the min and the max. That gives us our base range, which is 8 values, 0 to 7. And then we'll apply the shift outside. Another way to look at this is given any positive min-max where the min is less than the max, you can do max minus min plus 1 because the upper bound is exclusive. So max minus min plus 1, and then out here, your shift is equal to your minimum, which is effectively what Mr. Vega just did. Because if we take 5 to 12, well, 12 minus 5 is 7, plus 1 is 8, right? And that was our upper bound. Then we add the minimum on the outside as a shift. There's our constant 5. So if I have a range of 0 to 7, and I add 5 to each possible value, 0 becomes 5, 7 becomes 12. So my range has now shifted 5 values. Yep, this is me getting a random number between 5 and 12. So for int count equals 0, and count is less than the number of sets I want to perform, count plus plus. Inside of that for loop, I'm going to start doing a full set of swaps. So for int, I've tried some different names here. Let's call it index 1 is 0, and index 1 is less than the length of dice, because I want to go through every index. Now, inside of this for loop, I want to randomly choose a second index. So int index 2, I want to randomly choose this. How do I randomly choose an index in this array? How do I randomly choose an index from the dice array?
Use a random object that's the upper bound of the length of the dice array.
Well done. This is the answer every time you want a random index. Doesn't matter what array it is. As long as the array is not null, you can call next int where the upper bound is the length of the array, and you'll get 0 through length minus 1. So this is always correct, no matter how big or small the array is, as long as the array is not linked to 0 and is not null, you'll be fine. Now, I'm going to show you how to perform a swap. This is a very basic way to perform a swap. There are some other more elegant ways. This is the basic way. First, you need a variable to store the value at index 1. So die temp equals dice sub index 1. We're going to record that. Now, record the value at index 2 into index 1. Dice index 1 equals the value at index 2. So let's think about this for a second. We have one more line of code to write, but let's think about this for a second. That array of dice, when I look inside that array, what am I going to see? What does that array actually contain?
Contains 2 copies of the same thing.
Well, what is that thing, though? What specifically is that thing?
Die object.
No, not true, but thank you for the stab. It is not an array that actually has die objects inside. How do we keep track of objects out on the heap? What do we store? Addresses. We store addresses. So when I look inside that array, what am I going to see? 13 different addresses. Normally at the beginning, I'll have 13 different addresses. Okay? So when I make die temp and I say store in temp whatever is in index 1, what am I actually copying? What's in index 1? You're right, but what is it? What is stored in index 1? What kind of thing is there?
The address of the die.
Would not be, well, it's not really an integer. It's not an integer. It's an address in hexadecimal. But yes, it's a 64-bit address. So we're going to copy that address into temp. So now, index 1, as of line 36, index 1 is pointing to a die, and temp is also pointing to that same die, both of them doing this via address, right? Conceptually, if I wanted to roll that die, could I use dice index 1 to roll that die? Yes, I could. Because if I have the address of the object, I can tell it to do whatever's publicly available. Remember the keys to the car? The address is the keys to the car. If you give me the keys to the car, I can do stuff with the car, right? Okay, cool. So as of line 36, if temp, can I use temp to roll the die? Yes, I can, because it's the address to the same die. As long as I have the address, I can tell the object to do whatever it allows the public to tell it to do. And roll is a public method. So yeah, I can use dice sub index 1, or I could use temp to roll the exact same die. Does that make sense? Okay, so then line 37 happens. When I do line 37, what happens to the array? Stay with me, think with me. Line 37, what happens to the array? Mr. Felix. I have 2 copies of the address at index 2. So do you see why we have line 36? What's line 36 doing for us? Why is it doing that? You're doing well, keep going. That's exactly right. We have temp to preserve that address so we don't lose it. If we do this overwrite first, we will lose that address. And if everyone loses the address, the object gets deleted. So first I preserve the address, then I overwrite index 1 with index 2, and then I overwrite index 2 with that original index 1 address that we stored in temp. By doing that, I have effectively swapped the positions of these addresses in the array. Does that make sense? And I'm going to do that for every index in the array. I'm gonna go to a specific index, randomly choose a second index, swap their values, do that for every index in the array. And I'm going to do that between 5 and 12 times. So I will have somewhere between 65 and 156 swaps. Is that clear? Now we're going to revisit this method in just a little bit. You'll see why in a moment. But this will randomize all the dice in the array. So now let's talk about what it means to draw a die. Now remember, what we're doing here is the user expects that when it's their turn, when their turn starts, they have a full cup of 13, and we're going to randomize, we're going to shake that cup, we're going to randomize those dice so that we can draw the dice that we need, and we will get a random sequence, correct? Okay. We can give the user what they want without being literal. We don't have to physically remove the dice from the cup, because when just like we saw a moment ago in Shake the Cup, when I return a die or when I pass a die, what am I really passing along? What am I really passing? Am I passing the die object? Nope, not true. I'm passing the address of the die. When I go to return a die, I'm not returning the die object, I'm returning the address to the die. That means it's possible for more than one variable to be pointing to the same die object. If I want to return a die to the user, am I required to remove that die from the array? No, I just give them a copy of the address. Now they have access to the die too, and it's like I gave them the die. So what I do is I have determined I don't need to set my slots to null at all. I don't have to ever change my array in terms of length or content. I'll just change the sequence of the content. All right, so here we go. Here's die, and I have no special name for it. It's just die. It's die to be returned, right? In fact, here, let's do this. Let's call it the ret die, or return die. I want to just default that to null to start, and then I'm going to have a return statement of ret die. There we go. So when I call the draw die method, I'm going to start a local variable to hold the die I want to return, which just defaults to null. And I'm going to do some work to determine which die to return, and then I'll return that die. And here we go. Check this out. Now that my sequence of dice is random, do I have to choose a random index to return? No. The randomization happened before the draw, so it is random. Now that it's randomized, what can I do that would make my life a lot easier? The array is now in a random sequence. When the game wants a die, how can I manage that? That would make my life so much easier. Just pick the first one. Just pick the first one. What's the first index in an array? 0. Oh, okay. All right. So before I have served up any dice at all, when I've served up 0 dice, the index of the next die I want to give is index 0. Well, that's an interesting correlation. Oh, okay. Okay, fine. So then I return index 0. How many dice have I served up now? I've served up 1. What's the index of the next die I want to give up? 1. Oh, that's interesting. And then when I give that die up, I've served up 2 dice. What's the next index I want to serve? 2. Oh, huh. Ain't that a corker? All right, so check this out. If dice drawn is less than 13, if I have dice left in the cup, then the ret die equals dice at the index of dice drawn. Once that's done, dice drawn can increment. I'm purposely doing this as 2 lines, even though I don't have to. So I keep track of a counter of how many dice I've served up out of the 13 in the cup. The count tells me the index of the next die to serve. Once that die is served, increment the counter so that I know what the next index is. I declared that at the top right above our array. So it's a class level static. So it starts at 0. And then every time I draw a die, I just increment by 1 after I've drawn the die. My randomization has taken place. I know for a fact that my outcome is going to be unpredictable, but I can now serve the dice up 1 at a time. I never have to set my slots to null. I never have to reload the dice in a literal sense. I do have to reload the cup at the start of every turn, but what does reloading the cup look like at the start of a turn? Given this approach, how would you reload the cup at the start of a player turn? Yep. Set drawn dice to 0, or dice drawn, set dice drawn to 0. Shake the cup. Never have to recreate dice, never have to handle nulls. See, and the reason I'm showing this to you is because as computer scientists, as software developers, we have the ability to look at a problem, to look at the intended behavior, and we can solve it a number of ways. We often, as humans, will do it the literal way, we'll do it the brute force way, but there's often a more intelligent way to get the same result in an easier fashion, right? Yeah. Here's my array.
Oh, the new dice. That's what I missed.
There you go. Now, something else here, though. Okay, so that's if we want to reload the cup at the start of a turn, that's easy. Set the thing to 0, shake the cup, we're good to go. But what about the player who's having a bomb turn? And they have 2 escapes in hand, and they have 2 shots on the table, but they rolled 9 brains, and they want to keep going because they're idiots. Or maybe they have to keep going because they don't have a high enough score to beat the person who's currently winning, and people have gone out, so this is their last shot, right? They have to roll. How do we reload the cup with just brains without removing the other dice? Using this approach, how would you do that? So the player has 9 brains and 4 non-brain dice, and they want to keep rolling. They can't draw any more dice, so we have to load the cup with the brains again. Remember that rule? If you're out of dice, if you can't draw, you have to reload all the brains. So I want to reload the cup with just the brains, shake the cup so that I'm only randomizing the brains, and then serve up the dice that previously were brains one at a time. How do I do that, Felix? Mm-hmm.
And then pretty much as long as your first counter is greater than or equal to the array length, then and brain dice isn't null, then roll that array.
That's one approach. That's one approach. But we can still solve this problem without making another array. Oh, hey, I'm sorry, Mr. McCleary. Hang on. Go ahead, Mr. Bird. I can't change the color, not unless I build a brand new die. Remember that color is constant. There we go. Now we're getting warmer. So how should I swap the positions? What should be at the, given how I'm currently serving up dice, what should be at the beginning of the array and what should be toward the end of the array? I would disagree with you. Because let's consider that scenario. So Mr. Bird said toward the beginning of the array, we should put the brains, and then the non-brains would be toward the end of the array. Okay, fine. So indices 0 through 8 are previously brain dice, and indices 9 through 12 are the non-brain dice. What happens when I'm on a really super hot streak and I roll 9 brains out of the 9 reloaded dice? What's it going to serve up next? Now it's going to start serving up the dice that weren't back in the cup, like the dice that previously were shots and should still be on the table. But you're really close to the solution that would work. Instead of putting the brains at the beginning, put the brains at the end. Remember, we're serving starting from the beginning, going toward the end. If I go through my array and I swap the positions of non-brain dice to be at the beginning of the array, and then I set my dice drawn equal to the number of dice that aren't brains, now I have excluded those first 4 indices, and I'm only left with the last 9. Now I can serve up index 4, 5, 6, 7, 8, 9, 10, 11, 12, without accidentally serving up the dice that should still be on the table. So it's very close to what Mr. Bird said, just flopped around. Yeah. See, I don't have a Boolean. And if we did it that way, if we put the brains at the beginning, I have to change my draw logic. But if I put the brains at the end and I start my dice drawn after the dice that shouldn't be drawn, I don't have to change my draw logic. My draw logic is exactly the same. It just doesn't start at 0, it starts at 4. That's actually way better in my opinion because I don't have to write 2 bodies of logic to do the same task. The only thing that has to be different is how I load the cup, because those are two different processes. In one case, I load the whole cup. In the other case, I load only the brains, right? So if that logic is different, that's okay. But drawing the dice is the exact same process if I put the brains toward the end and the non-brains toward the beginning and set my dice drawn accordingly. Now, I'm not going to show you that code. I'm going to let you figure that out. I'm going to let you figure that out. But if you take this approach, managing the dice in the cup is super easy. Super easy. It's way less confusing. You don't have to build new objects over and over again. You build 13 dice and that's it. You're done. All you have to do is manage the counter correctly. Shuffle the array in an organized but random fashion. And then reload the cup in quotes, logically correct, and you're fine. All you're doing is managing an array. That's all you're doing. For many of you, not all of you, but for many of you, this is a simpler approach than what you've been doing. And I know that because I've had some of you show me what you've been doing. I've had many of you show me arrays where you're tracking colors. Why? I know your reason will be so that you know how many greens you have and how many yellows you have and how many reds you have, but that part is not the important part. The color determines what the last two faces are on the die, but the die knows how to do that if you'll just tell it what color it is. So the die takes care of that. What's really important is rolling the die and getting a face. That's the important part. So tracking an array of colors, you can't roll a color. The color won't tell you if you've been shot or not. But you know what has a color and will tell you if you've been shot or not. A die. So for those of you who've been keeping track of arrays of colors, stop that. It doesn't actually help you. I've had some people with individual ints. This is how many greens I have left. This is how many yellows I have left. This is how many reds I have left. Stop that. I mean, could you solve the problem that way? Yes, you could. But that means that every time you draw a die, you have to recalculate the probability. You can't use a constant probability because the probability is not constant. Plus, when you go to reload brains, you now have to go back and reset all the color counters accordingly based on how many brains you have. It'll still work. It's just more work. But yeah, you could do it that way. So people who keep track of arrays of colors, that's not helpful. People who keep track of ints, yeah, that'll work. It's just more work. This right here, super simple approach. I honestly don't know of a simpler approach, but I can see how Mr. Bird's approach, where he's making a new array every time you draw a die, that might be easier to implement, might be easier to understand. Sure, why not? That'll work. It'll work if you handle it right. Absolutely. All right, we good? Yeah, sure. What do you want to see? Do you understand what that code's doing? It's creating individual dice. Oh, you know what? I never showed you this in action, by the way. I want to show that to you. It's creating individual dice. So each one of those is a constructor call where I'm building 6 green dice, 4 yellow dice, 3 red dice. That's all that is. That's what we call initialization syntax for an array. Sorry. Did you get what you needed? So this is the syntax. You can follow the syntax and do it yourself. Okay.
Can you go back down to the draw die method?
Yeah, sure. Oh, also one more thing in Shake the Cup. Because we may be randomizing a subset of dice based on which dice we say are currently available, index 1 should not start at 0. It should start at whatever dice drawn is. That way, if we're just shaking a cup of reloaded brain dice, we're only randomizing the brains, we're not randomizing all 13. If we're doing a reloaded, refreshed cup, then it will do all 13 dice. Same method, same logic, different scenarios, works both ways. Love stuff like This method here is not done yet because it does not have the logic for what happens when you want to draw a die and there isn't a die to draw.
Yeah, that's what I was going to point out. I didn't know if you had covered that or not.
We discussed it in principle, but I'm not going to code it up. I'm not going to show that code.
Okay.
But I've given everyone enough of a base here that they could conquer that beast pretty easily. In fact, I will throw you a bone I have not thrown to any other class yet. Refresh cup. Okay. Dice drawn equals 0. Shake the cup. There you go. That's us refreshing the cup for a new turn.
Basically all I have to do now is find out how to make it so it's
The reason I made it public is because the game knows when a player's turn is over. The cup does not know when a player's turn is over. So the game knows when a player's turn is over. The game knows when to refresh the cup. Here is the private static method, reload brains. This is the method where you would reload just the brains. You would organize your array so that you know which dice not to serve up. And then you would shake the cup from there, shaking up only the brains. How do you store the brains? They never left the array. So all the dice are still in the array of the cup. Can I go through each die in the array and see what face it has? There you go. In fact, if you don't mind, I'm going to do this. I'm going to say, hey, I'm going to actually flip this around. I'm going to say, hey, if dice drawn is 13, then we have to call, I'm going to put that out and do reload brains. And then we'll do this bit of logic. And then we're okay. That method's now done. This method is finished. Reload brains is not done. You have to figure that out. Look, I'm giving you all sorts of bonuses because we're on the second day, right? All right, so here we go. Check this out. Organize the array so that non-brains are at the beginning. All the brains are at the end. The non-brains are at the beginning. Set dice drawn equal to the number of non-brains, non-brain dice. Call shake the cup, and you're done.
And so what's the point of reload brains?
What is the point of reload brains? That's correct. To load only the brains. And by load, remember, we're never actually removing the dice from the array. What we're doing is we're organizing the array and the counter that we're tracking such that we simulate that only the brains are back in the cup. We're just simulating, but we never actually remove the brains. We never actually make any new dice after the initial creation. We're just using the same objects over and over. All right, so hang on a second. Let me show you this thing in action. I'm going to bastardize main for this demo. Cup dot shake the cup. Die dot. I'm sorry. Die. No, that's not what I want to do. I want to do, once I shake the cup, we're going to do a for loop. for int I is 0 and I is less than 13, because that's how many dice I have for right now, I plus plus. I'm going to do die d equals cup dot draw die. And then we're going to tell the die to roll because it doesn't start with a face. And then we're going to sys out the die. This is me just proving that I can produce a random sequence of the dice from the cup. This is me just going through each die in the cup, rolling it. And the IDs there show you that 1, I have 13 dice, and 2, I only have unique dice. Right? If I hit play again, I'll get a different sequence, different outcomes. Yesterday when I did this demo, I only got shot once out of 13 dice, but all the reds were escapes, all of them. Ooh, a red brain, a red shot, and another red brain. That's 2 red brains. And then I got a green shot. I got 2 green shots just to balance it out. I'm probably dead. Yeah, I see 3 shots, 4 shots on there. But the point is, I have a random sequence of dice. And I go through every die in the cup. Yarf.
Why are we putting non-brains at the beginning?
So remember that the way that we're handling the dice is first we randomize, and then starting at the beginning, we serve up a die. When that die is served up, when it's on the table, we move our counter up by 1 so that we serve the next die. In other words, the die index 0 is considered on the table, so the next die to be drawn is index 1. What we're doing is we're simulating dice on the table. By moving the non-brains to the front of the array, 0 through whatever, we're simulating that those are on the table because we're going to change our counter to be equal to the number of these dice. In other words, if I have 4 dice that are on the table that are not brains, then they will be indices 0, 1, 2, and 3. So then what's the next index I want to serve up? 4. So if I have 4 dice that are on the table, the next index I want to serve up is 4. So if I set my dice drawn equal to the number of non-brain dice, and those non-brain dice are at the beginning, then only the dice I'm supposed to serve up are at indices 4 through 12. You don't have, well, we do that. That's what dice drawn means. Dice drawn is effective to dice in hand and those on the table.
Oh,
Yeah, so that's what that number is. That number is the number of dice on the table and in hand. Or rather, dice not in the cup. So there you go. This is it. All you have to do is one method, and the cup is done. One method and the cup is done. No, I mean, literally, this is the entire code. This is all of it. Since we made the cup's responsibility drawing and managing dice, and we changed how we did that, we only had to change cup. Game doesn't have to change, because game doesn't have to know how many of each dice we have. Game just has to analyze the dice as they're rolled. Well, where do the dice come from? They come from cup. Game doesn't care how cup does its job, only that it does it right. And the die knows how to roll. The cup doesn't have to roll the dice. The cup doesn't have to know how to choose a face because the die knows how to do that. The cup's job is purely to have instances of die and manage them. That's it. Just keep track of them. That's all cup has to do. So the code that you have here is complete code except for reloading the brains. And I gave you the pseudo for that. And then this class is done. Say again? Yeah, that's called semantic satiation, where you say or look at a word so many times that it loses all real meaning. I had the same problem with spelling the word poodle. If I try too hard, none of it looks right no matter what I do.
I always have to Google Wednesday. Either in the
Wednesday.
Wednesday, yeah. We're in the math test side of Google it. I thought that was the correct day.
Today is I'm married to 8-bit Nintendo Day. Wed NES. That's tomorrow actually, but we're talking about spelling Wednesday. Wednesday.
You have a bracket after die, array, dice.
So yeah, because I have a curly brace open and a curly brace closed. Yeah. Yeah, you're good. February? The drunkenest month of the year. February. Yeah, when I say it fast enough, I usually say February. Yeah, actually, no, I've got myself to say February. Yeah, from now on. February is the fast way. Yeah, February. Yeah, February.
First guy in Game of Thrones on the Game of Thrones calendar is the February month picture.
Ha ha. Tyrion for the win. All right, so refresh the cup. You know what? Technically, we could make shake the cup private, and that way game never has to call it. They can just call refresh cup at the start of every turn. And then shake the cup is part of that. So I'm gonna make this private. No big deal. Drawing a die is public. Reloading the brains and refreshing the cup. Refresh the cup is public because the game has to tell the cup when to refresh. But reload brains is private because the cup knows when to reload the brains. Yes, yes. It was due yesterday.
I turned it in.
Good.
Then I may or may not have tested it already.
Found bugs. Well, if you find and fix the bugs before we do, there's no penalty for a resubmission. If we grade it and we find bugs, then you're on the 24-hour clock. Yeah. Well, what that tells me is you didn't test it thoroughly before you turned it in.
Yeah.
May or may not have. Yeah.
Come on.
Come on, it's a complete hypothetical that came to your mind because it really happened. Mm-hmm.
Like I totally did.
Yeah, nope, that is not Schrodinger's outcome. All right, so yes, literally all you have to do is this, and then your cup is done. The rest of the game you got to figure out. But the cup is done if you do that. That's it. So I hope this helps get some of you unstuck, because when I have 18 non-delivers, then this is kind of important. Actually, if we remove those 3 people who effectively dropped, it's only 15 non-delivers. But 15, I don't know. I'm not going to say. I don't know. I'm not going to say. But I'm hoping that this gets you unstuck. And I also hope that it gives you some ideas on how you can approach solutions without being super literal about them. Right? You can approach them literally. If that's how you think, that's perfectly fine. That's usually how we start. But there are non-literal solutions to problems that can be really useful. Yes.
World, what would be like the average way of solving problems? Would be the brute force, or would be the intelligence?
In the real world, the first, because you're always asked to solve problems you've never solved before, right? You're rarely asked to solve the same problem twice. It happens, but it's rare. Normally, we solve it brute force to start because that's the easiest one to think about and implement. But in many cases, the brute force isn't sufficient because it takes too long. It's in fact, that's usually the number one reason. It takes too long, or it's too resource heavy. And so we have to come up with something faster and better. But often the brute force solution, though it may be slow or clunky, is still a good solution and fits the timetable, and we can get it before the due date. So it often works. And if that's the case, believe it or not, so many people are like, okay, I'll come back and make this sexy later. No, they don't. If it works and nobody complains, they get on to the next problem. They just do that instead. But if you know how to do it in a less brute force way, and you can still get the right result, and you can still make it by deadline, that's special in most cases. All right, we are done, guys. Thank you very much. Have a great day. I will be seeing you tomorrow at 10:30 because you will show up to class.
Will I?
Yes, you will.
I don't have to be here.
No, I won't.